The objective today is to explain the importance of firewalls to network security. Basically, firewalls are often categorized as either network firewalls or host-based firewalls. Network firewalls filter traffic between two or more networks and run on network hardware. Host-based firewalls run on host computers and control network traffic in and out of those machines. So your think right share here is, what are the two types of firewalls? So down below here is a bit of a table of contents for us, and I'll cover most of the topics here. But if you're planning on getting a network certification in addition to the Security Plus or before the Security Plus certification like the CompTIA recommends, then you might want to do some more research and learn more about firewalls on your own there. But for the sake of this class, I think this lesson will be pretty good in terms of what you need to know about firewalls. So basically, a firewall is like a long wall around your network covered in doors, and each door is a port in the firewall, and each door has a number, that's the port number, and a rule. The rule decides what is allowed to come through that particular door and where it should be going once it comes through. Don't get confused with firewalls and antivirus. An antivirus scans files that are already on your computer and helps to indicate which ones are viruses, as well as detecting when a new virus enters the system. Now, these both can work together terrifically. If something bad comes through the firewall and the firewall didn't detect it, an antivirus may be able to. This lesson isn't about antivirus. However, I just want to say a lot of security experts, that is like Steve Gibson from Security Now and Leo Laporte, he'll say, or they will say, that an antivirus may just be another attack vector, so a lot of antivirus is worthless. But I know for sure they will not say a firewall is worthless. So what will a firewall do? It'll just lessen the workload of an antivirus. Say that a firewall is a 2-lane border checkpoint that is fed by a 4-lane highway. Without the checkpoint, the border guards, that is the antivirus, can still stop all the cars, but it's much more work for them. With a 2-lane checkpoint, traffic that's in the wrong lanes will get turned away automatically, and the border guards have an easier time controlling who gets through. Now, your operating system, and or router most likely, has a firewall built in. And an important thing to remember, a firewall cannot check for infections, it can only control traffic. If you're really concerned, you can run a VM, download the file, scan it, and if something doesn't check out, you can roll back the VM to the previous state before you downloaded the malicious file. So working in virtual machines is a very safe way to do things, including opening files that you're iffy about or unsure of. Now, this term firewall originally referred to a wall intended to confine a fire within a building, in that sense to protect the outside world from the building that's on fire, which is almost the inverse of what we're talking about here. A firewall protects the inside of a person's network or computer. But let's start with the network. A network firewall can filter packets, and packet filters look at network addresses and ports of the packets to determine if they must be allowed, dropped, or rejected. So basically 3 things that it'll do: allow it, drop it, or reject it. And think about for a second, what's the difference between dropped and rejected? Interestingly, the first paper published on firewall technology was in 1988, when engineers from Digital Equipment Corporation developed filter systems known as packet filter firewalls, and this fairly basic system is the first generation of what later became a highly involved and technical internet security feature. And notice that, 1988, that's quite a while after the internet was invented, and a lot of people will refer to the beginning years of the internet as a means of just straight communication without defense thought of or built in. A lot of the early protocols are completely void of any security in mind. And now we've gone over this before, let's check that you're remembering what exactly is a packet. You have a nice little hint here to the right. So when a packet does not match the packet filter's set of filtering rules, the packet filter either drops it, that is silently discards the packet, or rejects the packet, so that's discards it and generates an Internet Control Message Protocol, also known as ICMP. Now conversely, when a packet matches one or more programmed filter rules, it is allowed to pass. And that's surprising to me. I'd imagine if you can't match all the rules, you would be rejected, or if you simply fail a single one, you would be rejected. But this is A little bit opposite of my common sense, and surprising that all you have to do is qualify under one rule and you'll be allowed to pass. I should have put a picture of Gandalf here shouting, "Thou shalt not pass," to a bunch of ones and zeros. That would have been good. Now, the bulk of internet communication in the 20th and early 21st century used either the TCP protocol or the UDP protocol. I guess I'm being redundant. The P in both of these words stands for protocol. So let's go more into the ICMP message format. ICMP is used by hosts, routers, and gateways to communicate network level information like error notification or querying network conditions. And when I say network layer, that is above the IP address, the ICMP messages carried in IP datagrams. So they're not being carried by TCP or UDP, which is an interesting difference to be aware of. Now, the ICMP message itself identifies the data type, the code, plus the first 8 bytes of an IP datagram that is causing the error. And all these facts here just to say that this is some additional information that you may be interested in, but the point in this slide is to just check your understanding of this particular protocol, the ICM protocol. It's simply to let the system administrator or whoever's looking understand the reason for the rejection of a packet. So with that said, what is the purpose of the ICMP message? And like they say, a picture is worth 1,000 words, even if the picture has 1,000 words in it. Here you see they ping 200.200 and so on. And the person had identified that there's no need for DNS resolution because they typed in the IP address instead of pinging, say, google.com. They just typed in the IP address. They knew it ahead of time. And the reply they're getting that error message is destination net unreachable. And in this next picture, this is nice because you get to see a successful ping with the DNS resolution right here, and some additional information such as the bytes. Well, I suppose that's no surprise, especially from the last slide. But interesting, here's the milliseconds it's taking the packets to get there, and then a TIO, a time to live, and they're all understandably the same amount. So with that in mind, I want you to think about, why would a packet have a time to live? Why would we need that? Especially in the context of something like this message where the destination is not reachable and you just keep sending the same information over and over. Why would we want to put a limit on that? And just because I can't help it, let me say one more thing about the ICMP message. This is a great link to go to learn more. I especially enjoyed a quote that said you can easily end up spending half a day trying to figure out why you're not getting a ping reply or echo reply from a web server, when in fact its firewall is configured not to reply to pings for security reasons. And fans of reading RFCs, it is RFC 792. So we'll learn more about the OSI model later, but for now, looking at its position in the OSI model, we can see that the ICMP protocol is sitting at what's called the network layer, and that's right alongside the IP. There are no ports used with ICMP. This is because of where the protocol sits in the OSI model. Ports are only used for protocols which work at the session layer and above. For those who took the class last year, or those who are taking the class now, or those who just know the OSI model, I have a really nifty way of remembering this acronym, and it's an important one. It's important to remember each level. Now, more than memorization, it's better to learn about each level and remember that information that way versus just straight up trying to memorize each layer. But let me go ahead and tell you my favorite acronym for this. It goes something like, please do not teach students pointless acronyms. So a firewall system can operate at 5 of the 7 layers of the OSI reference model. Now, most firewall systems operate at only 4 layers. That's the data, network, transport, and sometimes application layer. And I want you to predict here, before we go any farther, where do you think a firewall would reside in such a diagram as the one you see below here? So you have a Linux server that my workstation is communicating with, and over here you have another type of server, Windows 1, and in this image the Linux server is talking to the Windows 1 so it can go out to the internet and get that thing I'm looking for. The question again is, where do you think a firewall should be in this diagram? I have a video series called Fun with RFCs where we just read these really technical documents and I try to spice them up so we can make that experience a little more enjoyable. Education through entertainment is still education. So another firewall feature known as Stateful Packet Inspection records all connections passing through it and determines whether a packet is the start of a new connection, a part of an existing connection, or not part of any connection. So in your own words, what are the 3 states a packet can be in? And when you're done with that, now you can understand the denial of service attack model a little bit better. A DOS attack bombards the firewall with thousands of fake connection packets in an attempt to overwhelm it by filling its connection state memory. So notice right there, fake connection packets. If there's only 3 states, connected, new connection, or no connection, then that's something you want to keep in mind when you're trying to protect yourself or your company from a denial of service attack. Now, in inspecting all packets for improper content, firewalls can restrict or prevent outright the spread of network computer worms and Trojans. The additional inspection criteria can add extra latency to the forwarding of packets to their destination. So think right here, what is a con to using a strict firewall? Now that we've identified the con, let's talk about a pro. The key benefit of application layer filtering is that it can understand certain applications and protocols, such as the FTP or DNS or HTTP protocol. This is useful as it is able to detect if an unwanted application or service is attempting to bypass the firewall using a protocol on an allowed port, or detect if a protocol is being abused in any harmful way. So if that's happening, the ICMP message would be very useful in you identifying why the packet is being rejected. A firewall system certainly can operate at 5 of the 7 layers of the OSI model. However, most firewall systems operate at only 4 of the layers. I mentioned this before. We're talking the data, network, transport, and application layer. Now, based on the simplicity or complexity of a firewall product or solution, the number of layers covered varies. For example, a standard IP access control list, which is very popular and very familiar to cybersecurity experts, something you need to know about, access control list. That access control list on a Cisco router functions at what's called the OSI Layer 3 model. So if we go back real quick to figure out what Layer 3 is, there we go, network. So first is the physical, the bare metal, then data, and then network. So with that said, what layer do you think our school's firewall is operating on? Is the school's firewall protecting everyone on the network, or is it protecting just certain computers? If you look at the OSI model here, sorry about that. So when you're working with particular applications, maybe, is there a firewall there checking out each application and the data coming back and forth in that application or that website? Whatever you think here, there's no wrong answer except the answer that is not justified. And after this lesson, don't ask me about the school's firewall because I will tell you nothing. We're not going to touch it or mess with it at all. So the more layers that a firewall product or solution can cover, the more thorough and effective it can be in restricting access to and from devices. For example, a firewall that operates at only layers 3 or 4 can filter only on IP protocol information, IP addresses, and TCP or UDP port numbers. It cannot filter on application information such as a user's authentication or the commands that a user enters. And my think right here after reading that is, why wouldn't a company or organization have firewalls at every level? Why wouldn't it? I think you could write an entire paragraph answering that question. So that's it for the lesson. Let me just say in conclusion, if you filter based on IP addresses, for example, you can say that your firewall is filtering at layer 3. If you filter specific ports, that is, you shut all of them down except maybe one of them, let's say HTTPS, which is for something, I believe. I mean, HTTP is 80, but HTTP is less secure, so I imagine certain organizations would still even close that port. It depends. But what I'm saying is that if you're filtering at layer 4, you're filtering specific ports. And if your firewall inspects specific protocol states or data, that is to protect a denial of service attack, you can say it's operating at the layer 7, the highest layer. So the truth is that most firewalls do all these things in combination, and practically speaking, there is really no useful answer to the question, what layer is your firewall operating on? So with that said, I want you to connect this to our IB environment here, International Bachelorette. It says, what will these look like? What will we see if programmers are? And I probably should change that word from programmers to cybersecurity experts now that this class is specifically looking at security. But what I'm asking you is, this lesson, what type of lesson was this a lesson for? Open-minded people, principled people? Is it showing characteristics of caring? So at the end of each lesson, we'll look at these IB attributes and choose one to connect. And if you need a little help here, you can use a sentence starter like, today's lesson was all about being, and then choose one of these. I really like this exercise because it does a little emotional connection to a very factual lesson. Brain research shows if you connect information to emotions, you're more likely to remember that information. And then in my school, we always do a DOL, a demonstration of learning. And so to prove that you learned what I needed you to learn today, you're going to use this word bank, and you're going to tell me how our firewall would prevent a particular threat from happening. So as long as you're explaining with some or all of these words, then I'm happy. Again, just tell me how a firewall would prevent any particular threat from happening. And today I have 2 slides for extension activities. The first one is, if you want to keep learning, tell me more about a circuit level gateway. And the only thing I'll tell you is that a circuit level gateway is a type of firewall. So a little extra credit there at the end of your lesson. Tell me what that is. And if you want extra information on the OSI model because you just can't wait to learn about it in class, here you go.